So hello everyone, myself Dr. Ankit Kumar and I am Assistant Professor in the Department of Mathematics, School of Computer Science and Artificial Intelligence. So today's topic is binomial distribution. So in this distribution, we discuss about the properties of the binomial distribution, its application, its mean and variance, and some problem related with the binomial distribution. So what is the binomial distribution? So binomial distribution is a discrete probability distribution. This discrete probability distribution that models the number of success in a fixed number of independent trials, where each trial has only two possible outcomes, success or failure. So in the binomial distribution, we mainly talk about the two types of the possible outcomes. Two types of the possible outcomes. Two types of possible outcomes. So in this distribution, we consider only those events which have only two possible outcomes. For example, if we toss a coin, if we toss a coin, then there is a two possibility. Either we get a head, either we get a head or we get a tail. Okay. So in binomial distribution, these types of the problems are solved in this distribution. If we consider another example such that the if we count the number of pass and fail students in a class, then this is also a binomial distribution, because in all these two examples there are two cases of the outcomes. Either they are success or they are failures. So all these examples are in the category of the binomial distribution, and the number of success in a fixed number of independent trials is also available. So since binomial distribution is a discrete probability distribution, so we talked about the probability mass function. Okay. So if capital X follows the binomial distribution with parameter n, p and k, with parameters n, probability p and k number of successes evaluated. So the probability mass function PMF is given by this. So here p is missing. So px is equal to k is equal to nck p to the power k 1 minus p to the power n minus k. N minus k. So nck means n factorial, k factorial, n minus k factorial. This is k factorial. And p is p to the power k, and this is 1 minus p to the power n minus k. So p is the probability of success. P is the probability of success and k is the number of success. How many number of success occurred? Number of success. So if we saw this binomial distribution probability mass function, this or this, then here there are three parameters, namely n, K, and P. If we know three parameters, then all the problems are solved. So N is the total number of outcomes. N is the total number of outcomes. So N is the total number of outcomes. Okay. So total number of outcomes is provided in the question. K, how many success occurs? How many success occurs? How many success occurs? Also, P is the probability of success. P is the probability of success. So all these three things are provided in the question. You just put all these values in this distribution function and evaluate the value of the K. So I think you clear this. What is this probability distribution function? So this probability distribution function evaluated the K number of the success when there is a probability P of success is given and total number of outcomes given. So putting the value of P and K and N, you evaluated the value of K. So this is the concept of the probability distribution function. Now, we discuss about the mean. So mean of the probability distribution is N into P, N into P. This is the total number of outcomes. Total number of outcomes into probability of success. Probability of success. Okay, and this is N variance is NP 1 minus P. NP 1 minus P. So this is mean and this is variance. You also learn it because in some question only the value of mean is given and only the total number of outcomes is given. So you find using the formula mean the value of P. So these two formula are very important. So a useful way for students to identify this is a binomial distribution or not. So is the number of trials fixed in advance. So in this distribution, the number of trials is fixed. There are only two outcomes. We have previously discussed two outcomes. And probability of success of each outcome is same. The probability of success of the same for every trial. If we toss a coin 2 times, then the probability of getting head is 1 by 2, or probability of getting tail is 1 by 2. So in each case it doesn't change. In each case it doesn't change, and all the trials are independent. Getting a head does not affect the getting of tail if we toss a coin. Okay, so these are the main points of the binomial distribution, which is the requirement of the binomial distribution. Now we solve example 1. So Rahul is playing a small game during a break. He flips a fair coin 10 times, where getting ahead is considered a success. Getting ahead is considered a success. This is a main point. Since the coin is fair, the probability of getting ahead on the single flip is 0.5. Probability of getting head on any single flip is 0.5, means P is equal to 0.5. And Rahul is playing a small game. During a break, he flips a fair coin 10 times, meaning thereby the value of N is okay. Rahul wonders that the chance is that he will get exactly 5 heads out of the 10 flips. So what is the probability that he get exactly 5 heads when 10 flips are happen? If Rahul flip a coin, Rahul flip a coin 10 times and getting a head, and probability of getting a head is P is 0.5. So P is given, N is equal to 10 is given, and the question asks that what is the probability of getting exactly 5 heads, means K is equal to 5, you evaluate. For P x is equal to K is equal to 5, you evaluate the things. Okay. So P x is equal to x. What is the formula? N C K P to the power K 1 minus P to the power N minus 2. So NCK means 10C5 0.5 to the power 5, because Px is equal to 5, we evaluated. Okay. And 1 minus 0.5 to the power 10 minus 1. So this is 10C5 means 10 factorial, 5 factorial, 10 minus 5 factorial. This is 0.5 to the power 5. 1 minus 0.5 means 0.5 to the power 5. Okay. So 10 factorial means 10 गुणे 9 गुणे 8 गुणे 7 गुणे 6 गुणे 5 गुणे 4 3 2 upon 5 into 4 into 3 into 2 into 1. This is 10 into 5. This is also 5. So 5 into 4 into 3 into 2 into 1. We break into factorial. So 5 factorial is 5, 4, 3, 2, 1. 10 minus 5 means 5. So 5 factorial means 5, 4, 3, 2, 1. And 10 factorial means 10, 9, 8, 7, 5, 4, 3, 2, 1. So we cancel out this 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. And we also solve these things by the calculator. 0.5 to the power 5 and 0.5 to the power 5. So if you solve this thing, we get the answer 0.246. So I think this problem is clear to you. Now, this is a question also given. A factory uses an automated machine to manufacture electronic components based on the past records. Factory uses an automated machine to manufacture electronic components. Okay, so a factory uses an automated machine to manufacture electronic components. Based on the past records, the quality control team knows that each item produced by the machine has a 10% chance of being defective. So this is a key point. 10% chance of being defective. So 10% chance means P is equal to 0.10. Why 0.10? 10%. 10% means 10 upon 100. 10 upon 100. So 10 upon 100 means 0.1. Okay. During an inspection, 3 items are selected. So N is equal to 3. From the production line, the supervisor wants to know the likelihood that at most, this point is notable, that at most one item is selected. Among the 3 selected items turns out to be defective. What is the probability that the sample of 3 items, at most one will be defective? So what is the information? A factory uses an automated machine to manufacturing electronic components, and based on the past records, the probability or the chance of being defective an item is 10%. So if there is a 10% chance of being defective, so P is 0.10%. So 10% means 10 upon 100. So 10 upon 100 means 0. Okay. And inspection teams selected 3 items. So an inspection team selected 3 items means N is equal to 3. What is the probability that at most one will be defective? At most one means this. 1 or less than or equal to. So how we evaluate this? We evaluate this Px is equal to 0 and Px is equal to 1. It included x is equal to 0 and 1 both. So what is the formula? Formula is Px is equal to K is equal to NCK P to the power K Q to the power and R. This is 1 minus P to the power N minus K. So nck means n is 3 c k is 0, 3c 0, p is 0.1 to the power k means 0, 1 minus 0.1 to the power n is 3 minus 0, plus px is equal to 1 means k is equal to 1. So n means 3, k means 1, 0.1, 1 minus 0.1, 3 minus. Okay, so you solve this. 3c0 means 3 factorial, 0 factorial, 3 minus 0 factorial. 0.1 to the power 0 means 1, 1 minus 0.1 means 0.9 to the power 3, plus 3c1 means 3 factorial, 1 factorial, 1 minus 3 minus 1 factorial. 0.1 into 0.9 to the power 2. So you just solve this. So how we solve this? Three factorial means 3 into 2 into 1. 0 factorial means 1. 3 minus 0 factorial means 3 factorial is 3 into 2 into 1 into this is 1. This is 0.9 to the power 3 plus this is 3 factorial means 3 into 2 into 1. 1 factorial means 1 into 3 minus 1 means 2 factorial, 2 into 1. And this is 0.1. This is 0.9 whole square. So if we solve this, so 3 to 1, 3 to 1 cancel out, only 0.9 whole cube plus this is 2, this is cancel out, 2 into 0.1 into 0.9 whole square. So if you solve this, you get the answer, required answer. So I think this is clear to you, all of you, because there are 3 defective items and p is equal to 0.1 is asked in this question. P is equal to 0.1 is given in this question, and for at most 1 defective items will be evaluated. So this is. Now this question. So you can see also that if you evaluated from the slides, then all these things are given. There are 3 items, 3ck, 0.1, 1 minus 0.k, x is equal to at most. So at most means px is equal to 0, px is equal to 1. So you just put these values and evaluate all the answers. Okay. This is final answer. Now, a university library conducts a surprise inspection of returned books from first records. The library knows that 30% of the returned books have at least one page damage. 30%, 30% of the returned books. Okay. So 30% means there are 30% of the returned books means P is equal to 0.3. And on a particular day, 8 books are randomly selected means n is equal to 8. Okay. So P is given, n is given, and in these all these 3 parts, k is mentioned. So what is the probability that exactly one book? Exactly one book. So this is key factor, exactly one book. So exactly one book means k is equal to 1. What is the probability that at least 2 books? So what is the probability means at least 2 books means this at least 2, at least 2. What is the probability that the number of damaged books is greater than 1 but less than 6? Greater than 1 and less than 6. So if a university library conducts a surprise inspection of returned books, the librarian knows that 30% of the returned books have at least one page damaged. So if he is doing the experiment on 8 books, okay, so n is equal to 3, n is equal to 8 given, and the probability of finding a damaged book is 0.3%. So what is the probability that there is part A is what is the probability that there is exactly one book is damaged. So if capital X follows the binomial distribution with parameter n and p, and if X denotes the number of damaged books. Okay, so number of damaged books means this is NCK. NCK means 8C1 P to the power. P means 0.3 to the power. NCK P to the power K. K means 1. 1 minus 0.3 to the power. N minus K means 8 minus 1. So this is 8 factorial upon 1 factorial. 8 minus 1 factorial. 0.3 to the power 1. And this is 0.7 to the power 7. So 8 factorial means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 1 into 8 minus 1 means 7. So 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into. Okay, so this is a combination 0.3 to the power 1, 0.3 and 0.7 to the power. So I think this is cancel out. So the resultant is 0.8 plus 0.3 plus 0.7 to the power 7. So you evaluate these things by calculator and your A problem is part A is solved. Now we move on the second part, B part. So what is the B part says? B part says that at least 2 books. So at least 2 means Px is greater than or equal to. So at least 2 means 2 are more than 2. So it goes to 2, 3, 4, 5, 6, 7, 8 up to infinity. Okay. Okay. So if we go through this formula 1 minus P x is equal to 0 and x is equal to. So why we use this formula? Because we know that the total probability P, the total probability is equal to 1 equal to 1. So if Px greater than or equal to 2 means P contains 2, P contains Px is equal to 2, P plus Px is equal to 3 plus Px is equal to 3 is equal to up to dot 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 infinity. So if we minus these two probabilities from 1, we get the required result for 2 because it contains the probabilities equal to or more than 2. Okay. So if we subtract 0 and 1 from this, then this is for 2 and more than 2. So how we evaluated this? 1 minus n, what is n? N is 8, n c k, n c 0, p to the power k, p means 0.3 to the power k, k means 0 plus into 1 minus 0.3 to the power n minus k. N minus k is 8 minus 0. So this is probability for 0, but Px is equal to 1. So 8C1 0.3 to the power 1, 1 minus, this is 1 minus 0.3 to the power 8 minus 1. So what will be this becomes 1 minus 8C0 means 8 factorial, 0 factorial, 8 minus 0 factorial. 0.3 to the power 0, into 1 minus 0.3 is 0.78 plus 8 C1 means 8 factorial, 1 factorial, 8 minus 1 means 7 factorial. This is 0.3 to the power 1, 0.7 to the power 7. So how we will solve this? 1 minus 8 factorial, 0 factorial means 1 into 8 factorial. Okay, so this 8 factorial cancel out, 0.3 to the power 0, 1, only 0.7 to the power 8 is here. This 8 factorial means 8 cross 8 cross 7 cross 6 cross 4, then 5 cross 4 cross 3 cross 2 cross. This is 1 factorial means 1 factorial, 1 cross 7 factorial means 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross, which is 7, this cancel out. And this is 0.3 to the power, 0.3 to the power and 0.7 to the power. So if we evaluate these things, so if we write it in a final manner, 1 minus 0.7 to the power 8 plus 8, 0.3 to the power 1, 0.7 to the power. So if we solve this thing, then we done for option. So this is the mechanism. Now we will solve for the third case P, when what is the probability that the damaged books are lies between 1 to 6, greater than 1 but less than 6. So what is the probability? So how we evaluated this? So we just see here. P greater than x less than 6. So this is contains P greater than 1 means it run from x is equal to 2 plus Px is equal to 3 plus Px is equal to 4 plus Px is equal to 5 plus Px is equal to 6. No, only 5 because less than. Okay. So we evaluate these two. So how we evaluate these two? So Px is equal to 2 means this. Px is equal to 2 means 8C2. P to the power 0.3 to the power 2. And 1 minus 0.3 to the power n minus k means 8. N is 8 and k is 2. So this is 8 minus 2. So you put the values and evaluated 0.2965. Similarly, for the case Px is equal to 3. So Px is equal to 3 means, what is the formula? Px is equal to x formula is Px is equal to k means nck p to the power k 1 minus p to the power n minus k. This is the main formula. So n is given 8, c is given 3, k is given 3, p is given 0.3 to the power k is 3, 1 minus 0.3 is given, n is 8, k is 3. So you just solve 8c3, 8c3 means 8 factorial, 3 factorial, 8 minus 3 factorial. Okay. This is 0.3 to the power 3, this is 0.7 to the power 8 minus 3, 5. So you just solve 8 cross 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross. Similarly, this is 3 cross 2 cross 1. 8 minus 3 means 5. This 5 cross 4 cross 3 cross 2 cross. You can also evaluate it by the calculator also. So this is 0.7 to the power 5. So if we solve, this is 3 to 1. This is 3 to 1 cancel out. 5, 4. This is 5, 4. This cancel out. Okay. And this is 3 to just 6. So this is 6 cancel out. So 8 into 7 only 56 is remaining. Into 0.3 to the power 3 means 0.027. And 0.7 to the power 5 means 0.16807. If we evaluated this, we find the answer 0.254. So this is the required answer. So if we put all these values, Px is equal to 3, x is equal to 4. Similarly, we evaluate for x is equal to 4 and x is equal to 5. So we find out the required result and we put all these values in this formula and find out the result where it is correct or not. Okay. Now there are some practice problems in which we find the result. So this is very important practice problems. I will solve one by one. In question 1, it is mentioned that a teacher knows that each student in a class has a 60% of chance of passing a surprise quiz. If a quiz is happened, then there is a probability of passing up students is 60%. The result of different students are independent. If 5 students are selected at random, what is the probability that exactly 3 students pass the quiz? So the probability of passing a students is 0.6%. P is 60%. So 60% means 60 upon 100. So this is 0.6. So this is chance. Okay, it is given. The result of different students, 5 students are selected. So 5 students are selected means n is equal to 5. So what is the probability that exactly 3 students are occur? So P x is equal to 3. So what is the formula? P x is equal to k is n c k p to the power k 1 minus p to the power. Okay, so x is equal to 3 means 5 c 3. P to the power k means 0.6 to the power 3. 1 minus p 0.6 to the power 5 minus 3. So if we evaluated this, 5c3 means 5 factorial, 3 factorial, 5 minus 3 2 factorial, 0.63. This is 0.4 to the power 2. If we evaluated this by the calculator, or if we write it 5 into 4 into 3 into 2 into 1, 5 factorial. 3 factorial is 3 into 2 into 1 factorial. And 2 factorial is 2 into 1. So this is 3 to 1. 3 to 1 is cancel out. 2 to the 4. Okay. Into 0.6 to the power 3 into 0.4 to the power. So this is 10. 5 to the 10 into 0.6 to the power 3. And 0.4 to the power 2. If we evaluated this, then we get the answer 0.346. Okay, so this is the answer. Now, this we moving on the second part. That a hospital study shows that 20% of patients arriving at an emergency ward require immediate attention. So there is a 20% of patients have serious issues. So P is equal to 0. P is equal to 20 upon 100. So steady, so 0.2. On a particular day, 10% 10 patients are arrived independently. So 10% arrived, and there is a chance of being serious is 0.2. So n is equal to 10 and p is equal to 0. So find the probability that exactly 3 patients require immediate action. So p x is equal to 3 means we apply the formula this n c k, n is 10, c k means 3, p means 0.2 to the power k, k means 3, 1 minus 0.2 to the power n is 10, 10 minus 3. So if we solve this one here, we can solve this 10 factorial, 3 factorial, 10 minus 3, 7 factorial, 0.2 to the power 3, 1 minus 0.8 to the power 7. So if we solve this, we find the answer 0.20. Okay. Exactly 3 persons are correct. Now the second part, B part. How we solve this B part? B part is at least. So at least means Px is equal greater than or equal to 2. So this is at least means Px is equal to 0 plus Px is equal to Px is equal to, so 1 minus Px is equal to 0 means n is 10, C 0. P is 0.2 to the power 0. 1 minus 0.2 to the power 10 minus 0. So this is the probability for Px is equal to 0. Now, Px is equal to 1 means 10 C1, 0.2 to the power 1, 1 minus 0.2 to the power 10 minus 1. Because this is formula 10 Ck, 0 P to the power K, 1 minus P, 0 n minus K. So this is the probability for Px is equal to. So if we solve this one, so 1 minus 10 C0 means 10 factorial, 0 factorial, 10 minus 0 factorial. Okay, 0.2 to the power 0, 1. 1 minus 0.2 to the power 0.8 to the power 10 plus 10 C1 means 10 factorial, 1 factorial, 10 minus 1 factorial. Okay. This is 0.2 to the power 1, 0.8 to the power 9. If you solve 1 minus 10 factorial, here 0 factorial is 1 and 10 factorial is also. So 10 factorial, 10 factorial can cancel out, 1 factorial is 1. So nothing is this 0.8 to the power 10 plus this is 10 factorial upon 9 factorial. 10 minus 1, 9 factorial into 1 factorial. 0.2 to the power 1, 0.8 to the power 0. So if we cancel out, then this becomes 10, 10, this becomes 10 because 10 cross 9 cross 8 cross 7, 6, 5, 4, 3, 2, 1, and if we expand this, then only 10 is remaining. So if we solve this one, 1 minus 0.8 to the power 10 plus 10 into 0.8 to the power 9, we get the required answer. Okay. Now we moving on this part, third part. A National Cricket Academy is conducting selection trials for an upcoming tournament. Based on the records, it is known that 40% of the players who attend the trials are selected for the final team. The selection for each player is independent of the other. On a particular day, 9 players participate in the trials. So find the probability that more than 3 but fewer than 7 players are selected for the final team. Find the mean number of players and find the variance. So this is very important question. So we discuss about. So it is not that the 40% players who attend this. So P is given. We solve here. We make this part. So P is equal to 40%. So 40%. This is 40 upon 40 upon 100 means 0.4. On a particular day, find the probability that more than 3 but fewer than 7 players are selected for the final team. So you just find the values of P greater 3 x to 7. So what is how we evaluate this? P x is equal to 3, Px is equal to 4 plus Px is equal to 5 plus Px is equal to 6. So if we evaluate this, we find the values. So how we find these values? We using the formula Px is equal to K, NCK, P to the power K, Q N1 minus P to the power N minus K. So N is given. What is N? N is 7. N is 9 players. Okay, N is 9. So N is given, P is given, K is also given, K, X is equal to 4, 5, 6. You can evaluate. We also discuss this is mean and variance. So what is mean? Mean is NP, N is 9, and P is 0.4. So this becomes 3.6. And variance is NPQ. So NPQ means NP 1 minus P. So this is N is 9, P is 0.4, one we evaluated here. There is some space variance. Variances NPQ, NP1 minus P. So N is 9, P is 0.4, okay, and 1 minus 0.4. So you just evaluate the things and find the answer 2.16. So I think this is very beneficial for you, and this is summary part. If you will wait, what is the summary? So summary of the this is a discrete probability distribution, okay, with probability mass function. Probability mass function is Px is equal to k is nck p to the power k 1 minus p to the power n minus k. This is the main thing, where n is the total number of outcomes, p is the probability of the success, k is the k is the favorable number of outcomes, or the total number of success achieved in n number of experiments or n number of trials. Okay, so this is the probability mass function of the binomial distribution. So I think this video is very helpful for you. Please like the video and subscribe my channel. Thank you.